Okay, Ron. Now on this video we will make a quick revision about the chapter 6, linear equation or coordinate plane geometry. That's very basic, so let's start. First one, you need to understand graphing ordered pairs from a table of the value. As you see, there's a table. There are x values, and according to that x value, we have y. So we will make an ordered pair with these values. Don't forget, when we have ordered pair all the time, the first value show the x, and the second value is the y value. According to that, you can write -3 and 4 is the first point. So here, as you see, -1 and 1 is the second point. Then what we have? 1 and x is 1, y is -2. 1 and -2. And the last one is 3 and -5, the -5. So don't forget. Let's take that one. At the first, let's use this value. -3 and 4. The -3 is x value. As you see, we have x-axis is horizontal, and the vertical of axis is, we call it y-axis here. Now, on the x-axis, -3. As you see, there's a number, -3. And the y value is 4. So -3 and 4, the coordinate plane is that one. So -3, count on x-axis, find the -3. Positive 4 goes up 1, 2, 3, 4, and put the points here. You don't need to put any sign on the numbers. So this point is represented by the number -3 and 4. So this point's name is -3 and 4. The next point is -1 and 1. Sorry, that's -1 and 1. X is -1, y is 1. As you see, -1 and 1. Okay, these names is, that's -1, the -1 and 1. Okay, let's continue. 1 and -2. X is 1, y is -2. Put the point. And 3 and -5. X is 3. 1, 2, 3, 4, 5. And the -5 is going to be here. These are all points represented by the ordered pairs. That's the first thing you need to understand. Locate the points. Let's give another example. Time and temperature. So here, time and temperature. As you see, temperature is constant here. It doesn't change. So it's all the time 3. And don't forget, when we talk about time, x-axis all the time show time. So these are x values, these are y values. I will put all the points, 1 and 3. 1 and 3. 2 and 3. 2 and 3. 4 and 3. 6 and 3. 7 and 3. So x is 1, y is 3. X is 2, y is 3. 4 and 3, 6 and 3, 7 and 3. As you see, when y-axis is constant, we have only 3 as a y-axis. That makes a collinear lines on the 3. So it's parallel to these collinear lines. When you draw a line, it's going to parallel to x-axis. So that's all. Don't forget, time cannot be negative. At the moment, I don't need this side because time cannot be negative. Let's change the color for the second table. Okay. X is 2, -1. 2 and -1. X is 2, -1 here. As you see, this is 2 and -1. 2 and 0. 2 and 0. X is 2. Y is 0. Be careful. Y is 0 here. The origin is 0, 0. So when y is 0, the point on the x-axis. Now 2 and 2. Here, 2 and 2. Where is it? 2 and 2. 2 and 3. As you see, we have the same value here. I will only circle a blue circle. It's exactly the same point with the 2 and 3. As you see, these values, these values. So the same point. 2 and 4. That's the point. As you see, they are collinear lines. When you draw a line here, that parallel to y-axis. When the x is constant, so the collinear lines, when you draw a line on these collinear points, when you draw a line on these collinear points, it's going to be parallel to y-axis. That's the idea. So they line up on the 2. When the constant value. So x is constant here. It doesn't change. Let's continue. completing a function table. So function means there's a y value. It's related to the nx, 4x minus 2 on the example. This is our rule. We will substitute x value, so we will calculate y value. Let's try. What is our rule? 4x minus 2. What is x? The given input minus 1. 4 times, don't forget, when you substitute a number instead of a variable, use parentheses. 4 times minus 1 minus 2. 4 times negative 1, negative 4 minus 2, negative 6. So, if I substitute 0, 4 times 0 minus 2, minus 2. 4 times 1, 4, minus 2, 2. Oh, sorry, 2, 4 times, now the input is 2, I'm going to write here 2, 4 times 2, 8, minus 2, 6. This is input, this is output, that's the second thing. We make a table, as you see, we have an x value, we have a y value. So what can we do with this x and y value? We will write ordered pair, as you see. Now, when we have a rule, there is a yx and 2x. So we make a table with input, rule, and output. X and y makes an ordered pair. Don't forget all the time. First one is x, second one is y. Now, 2 times negative 2, y, x is negative 2. Instead of x, I wrote negative 2. 2 times negative 2, negative 4. In ordered pair, x, first one is negative 2x, and the y is negative 4. 2 times minus 1, 2 times minus 1, negative 2, minus 1, so negative 1 and negative 2 ordered pair. 2 times 0, 0. So it's passed through the origin. 2 times 1, 2, so 1 and 2. 2 times 2, 4, 2 and 4. Let's locate these points. Negative 2, negative 4. Here, negative 1, negative 2, 0, 0, 1, 2, 2, 4. As you see, these are the points, order of pair for this function or for this equation linear. That's the second thing. We locate the points, we already know how to locate it, and how we find the value. There are input values, then we calculate the output values. Then write the ordered pair here. Next, linear function. Linear functions we call linear equations. So we call it linear equations. Y equal mx plus b. This is the form. M and b are numbers such as y equal 2x minus 1. Y equal 1 over 2x plus 3. Y equal negative 3x. So I don't write anything. That means plus 0. We don't write plus 0. So it's still a linear equation. M and b are numbers. Y and x are variables. This type of equations called linear equations or linear functions. Sorry. How we graph these linear functions? As you see, we already know how to make functions works. We write input, rule, and output, and we use some input to calculate output. Negative one. What is our rule here? 2x plus 1, the rule. 2 times minus 1 plus 1. 2 times minus 1 minus 2 plus 1 minus 1. Minus 1 and negative 1. Negative 1 and negative 1. Let's write 0. 2 times 0 plus 1, 1. 0 and 1. 2 times 1 plus 1, 3. 1 and 3. Let's put these numbers, locate on the coordinate plane. Negative 1, negative 1, 0 and 1, 1 and 3. So there must be a line that passes through these points. Let's draw a line that passes through these points. Okay. I think this line passes through to that point. This green line, let's make it a little clearer. Come on. Okay. This green line, all points on this green line are solution of this equation. So this is y equal 2x plus 1. If you choose any point, that's this point. This point is a solution. This is 0.5 and 2. If you write on rule that input 0.5, output gonna be 2. Let's try. 2 times 0.5 plus 1. 2 times 0.1, 1 plus 1 equal 2. So as you see, 0.5 and 2. So any decimal point you can use on the x value. Any point on the x value, it has a y value. So we call it linear equations or linear function. That's it. This is the last things about ordered paired points tables and linear equations. You locate the points and draw the line at the end. If it's asking the graph the linear equation, we graph a line. Midpoint segment, that's the last section of our book. Let's change the color of the line and increase the thickness a little. When we talk about segment, we talk about, as you see, a part of the line. In mathematics, when we talk about line, it's going to infinity. But when we talk about mid-segment, as you see, that's a part. Why? What is the difference, you can ask? It ends here, so it has two endpoints. When we have a number line, and let's say this value is 3, this value is 11. What is the midpoint? What is the value of midpoint of this mid-segment? This is only x, so number line, we have only x value. Let's say this is A, this is B. So we will tell it midpoint of the, x value of the, let's call that midpoint. X value of midpoint equal x value of A plus x value of B divided by 2. 3 plus 11, as you see, A is 3, B is 11, divided by 2, it's equal 7. 3 plus 11, 14, divided by 2, 7. So this value must be 7, and this is the midpoint of this segment. It's very easy. It has only x value. It's really easy. We add them and divide it by 2. But if we have a line on the coordinate plane, let's put here a line. That's very good. It's okay. And we know something surely. We know how to, this point, it's 5. On the x value is 5 and 2. And this point, I'm sorry, I couldn't draw it very well. Let's change that one. That's better. Okay. And this point, -4 and -3. X is -4, well, y is -3. Probably, I don't know where is the midpoint. It's going to be some place here. We don't know. But let's call midpoint is M. How we calculate it? For x value, x of the midpoint, let's say this is B, this is C, the point B and C. X of the midpoint equal x of the B plus x of the C divided by 2. As you see, it's written here. I'm going to use the rule. What is the x of the B? -4. -4. What is the x of the C? Is 5 plus 5 divided by 2. 1 over 2. -4 plus 1. -4 plus 5 is 1. 1 over 2. 1 divided by 2, 0.5. This point, x. Now let's find the y value. The rule is written here. The same idea, y of the midpoint, y of the B plus y of the C. It's equal, y of the midpoint. It's equal, y of the B is -3, -3. Y of the C is 2 divided by 2. -3 plus 2, it's equal -1 over 2. So -1 over 2. So it's here. So this is -1 over 2. This is 1 over 2. This is the midpoint. So what is the coordinate of midpoint? You need to understand that one. Coordinate of the midpoint, x is 1 over 2 and y is -1 over 2. This is the midpoint of the segment, the coordinate of the midpoint of the segment, and that's the end of the video. Thank you for listening.